Images are all around us, but have you ever stopped to think about the different types that exist? From black and white to vibrant colors, each type of image has its unique characteristic. In this video, we'll dive into the world of images and explore the difference between monochrome, grayscale, color, and halftone images. We'll also discuss their Python code so that you can visualize that image in real. So let's get started. First comes the monochrome image, which is a binary image that contains only two colors, black and white. So here the pixel is either black, that is 0, or 255 means white. So in order to create this image, we will first import the NumPy library, which is the library for efficient numerical computations in Python. And we know this monochrome images or the binary images are used in fixed machines, scanning documents, and binary image processing. We will discuss all these image types. The only difference will come in IMG part. And this, so import numpy's NP will remain in all the codes. Import matplotlib.pyplot will also remain. All this will remain. So only change will come in the IMG part. So here we are creating a two-dimensional array, where we are creating an array filled with the zeros here, np.zeros. So 256 into 256 means the shape of the array, which means it has 256 rows and 256 columns. Now the data type of an array, np.uint8, is an unsigned 8-bit integer, which means each pixel value can range from 0 to 255. And this is the common data type for image pixels. So we are getting an image which is 256 into 256 array filled with zeros, where each pixel value is an unsigned 8-bit integer. In order to create a monochrome image, we will set a square region of the image to 255. So here what we are doing, we are slicing the array IMG to extract a subset of pixels. So where the syntax is array row start to row end, column start to column end. So row start 100 to 200 means extract rows 100 to 199 inclusive. Similarly, extract columns 100 to 199 inclusive. Is equals to 255 means assign the value 255 to all pixels in this extracted region. So we are getting 100 into 100 square region starting at position 100, 100, that is all set to white here. And then we are importing this matplotlib library, which is a popular plotting library in Python. So here pyplot module is imported and assigned the alias plt. Next we display the image using matplotlib. So where we are getting the image data to display, which is a two-dimensional array image. CMap is equals to gray means specify the color map to use. Here we are using grayscale image, which means the image will be displayed in shades of gray. And finally we are displaying the plot. So when we run this code in Google Colab, we are getting a 256 into 256 image with a white square in the middle surrounded by black pixels. Here the white square is 100 into 100 pixel in size starting at position 100 and 100. So this, remember this code, import numpy's np. Only difference, first we are creating the all zeros image, then we are creating and slice of the white array, that is 100 into 100, 100 into 200, 100 into 200, that is set to white. Rest all is black here, and finally we are showcasing that image. Now we want to show the grayscale image, which is an image that contains shades of gray from black to white. So here each pixel has a value between 0 and 255. So we will start with the NumPy. And these type of images, grayscale images, are used in medical imaging, say X-ray, CT scan, document scanning, and image processing. So here the difference shall come only in the IMG part. That is, we are getting this random.randint array. That is, we are creating a two-dimensional array where we are creating a array of random integers. 0 to 56 means the lower and upper bounds of random integers. So here integers will range from 0 to 255. Now the size 256 means the shape of the array, which means it has 256 rows and 256 columns. So it will represent a 256 into 256 pixel image. And finally, the data type of the array is an unsigned 8-bit integer, which means each pixel value can range from 0 to 255. So we are getting this image of 256 into 256 array filled with random integers between 0 and 255. And finally, we are importing the matplotlib library. And then we are displaying the image. So where we are creating a two-dimensional array image CMap is equals to gray means we are using a grayscale color map, which means the image will be displayed in shades of gray. And this is necessary because image is a two-dimensional array. Otherwise, the matplotlib would display the image as pseudo color image if we won't use this CMap part here. Next, we are displaying the plot. So when we are running this code, we are getting a 256 into 256 grayscale image with random pixel values between 0 and 255. That is white part. Next comes the colored images. Now this colored image is an image that contains the combination of red, green and the blue colors. So each pixel has three values R, G, B ranging from 0 to 255. So here also all code will remain same. Only difference is IMG part, and here we won't use CMap part because we are not showing the gray color image. So we will avoid that CMap part here. And the colored images are used in digital cameras, smartphones and computer graphics. So first we are importing the NumPy library here, and then we are creating this image part. So here we are creating three-dimensional array. So first we are generating an array of random integers. 0 to 56 means the lower and upper bounds of random integers. So here integers will range from 0 to 255. Now see the main difference between the colored and grayscale image. That is the shape of the array, which means it has 256 rows, 256 columns, that is the width. Rows means height, width means columns, and finally we are having three channels, that is the depth, which is representing the red, green and blue color channels. And finally we are having the data type of the array, which is an unsigned 8-bit integer, which means each pixel value can range from 0 to 255. So we are getting an image of 256 into 256 into 3 array image filled with random integers between 0 and 255. And finally we are importing the matplotlib library, which is a popular plotting library. Here pyplot module is imported and assigned the lisplt, and then we are displaying the image. So here we are getting a three-dimensional array image. We don't need a CMap here because image is already a three-dimensional array with RGB channels, which matplotlib can interpret directly. We use CMap only in the grayscale images, otherwise matplotlib gives a pseudo-random image. And then we are displaying this image where we are getting a colored image with random pixel intensity between 0, that is a minimum intensity, 255 is a maximum intensity for RGB image here. Now we'll have a half-toned image. Now this half-toned image, I think we all have seen the newspapers or read the newspapers at some point of the time. Here the images do look like gray levels, but if we look closely, all the images in the newspapers generated are usually using black color. Even the images that you see in most of the books are generated using black color on white background. In spite of this, we get an illusion of seeing gray levels. So this technique to achieve an illusion of gray levels from only black and white levels is called half-toning. So this half-toned image is an image that uses pattern of tiny dots to create an illusion of different shades of gray or color. So this technique is used in printing to stimulate continuous tones. So here we will create a half-toned image here. So first of all, this type of images are used in printing newspapers, magazines and books, where half-tone technique is used to create images with limited number of colors. So here we are first importing the NumPy library here, and then we are creating this image. So first of all, we are creating a two-dimensional array where we are generating an array of random integers. 0 to 256 means the lower and upper bounds of random integers, where integers will range from 0 to 255. Size 256 to 56 means the shape of the array, which means it has 256 rows and 256 columns. And finally, the data type of the array is an unsigned 8-bit integer. So here we are having first the image of 256 into 256 array filled with random integers between 0 and 255. Now in order to create this half-tone image, we will create another array where np.zeros will generate an array filled with zeros here. So we have filled all the zeros, and then the shape of the array, which means it has 256 rows and 256 columns. So d type is a d type here. So half-tone image is now a 256 into 256 array filled with zeros representing a blank image. And then we will create a loop that will iterate over each pixel in the IMG image. So it will check if the pixel value is greater than 128, that is IMG ij greater than 128. If it is so, it sets the corresponding pixel in the halftone image to 255, that is white. If the pixel value is not greater than 128, then it sets the corresponding pixel in the halftone image to black here. And this loops applies a thresholding operation to the image where each pixel value above 128 are set to white and pixel value below 128 are set to black. And then we are importing the matplotlib library and then displaying the halftone image. So here we are displaying the image and then we are using a two-dimensional array. Here we are using the CMap. Except in the colored images, we will use CMap everywhere because we are using a grayscale image. So the image will be displayed in shades of gray and finally it will display as the image where we will get a 256 into 256 halftone image where pixels with the values above 128 are white and pixels with values below 128 are black. So it is creating a binary image with thresholding effect. So this is how this image is looking like. Now the question arises how to convert this colored image to grayscale image without using this inbuilt function. So here first of all we will create a colored image. So here we will use a simple formula, that is gray is equals to r plus g plus b divided by 3 here. This is the formula here. So we'll use this one. So first of all we will import the numpy library as usual here and then we will define the colored image. Then we are converting this image to the grayscale. So we are defining this grayscale image here and then we are using this formula where we are using gray image, that is img rgb divided by 3 and then we are showing this grayscale image here. Now how to convert the grayscale to colored image? So here we are having all code same matplotlib, we are displaying this library and then we are first loading the grayscale image and then we are converting this. So we are adding a constant color to each pixel. So we are adding this grayscale RGB. So we are adding the constant color to each pixel in this image and we are displaying this colored image finally. In case we want to add specific color, we can modify the code to add a constant value. So here we can add a red tint using this code here. So here first of all we are loading grayscale image, then we are converting it to the colored scale image when we are using this loop here and we are adding a red tint here and finally we are displaying this image here. And this is how we are getting the image. And that's the wrap. Understanding the different types of images, monochrome, grayscale, color and halftone can enhance our appreciation of the visual world. So with this knowledge, we can unlock new creative possibilities and explore the endless ways images can be used to communicate, express and inspire. So thanks for joining us onto this journey into the world of images. Thank you.